All right, time to revivify this old Gibson Skylark. So I'm going to start by cutting the old power cable out. And I will leave the old leads connected for now, just to remind myself where they go, though there's not much mystery to it. And we're going to do a similar thing to the leads on this old Astron dual 20 microfarad cap. Now this has this riveted holder, and over the years someone had put some white silicone underneath it that did not really stick to the chassis, so they then put some black electrical tape, which left some gunk here. I'm going to get this all out, and I'm going to try to move these two wires to the side so I can drill out this rivet. And I'm going to do that off camera because I'm going to move the whole thing to over my trash can so all the little bits of metal don't go flying everywhere. All right, that's out of the way. Nice clean hole. I deburred both sides of it with a countersink bit. Now I'm going to get this black wire out of this ground lug, make sure this ground lug is tight. I'm going to remove this old polarity death cap from the same ground lug and from the other side of the power switch. And I'm going to remove these red wires from these pins on the rectifier and the screen node there, and that resistor is a 1/2 watt, and that is acting as the choke in this amp, and I think that's a little underpowered. I'd prefer to bump that up to something with a little more reliability. So let me show you the after that. I'll show you some of the soldering on this, but on some things like this, it just really slows down the repair too much if I'm filming every little bitty thing. Maybe I'll show you one joint on one of the cathode bypass caps or something. Jumping back in for a second to explain one other thing. This is the hot from the power cable, and it's going to this part of this fuse, and the other side goes both to one side of this lamp and to one of the primaries on the power transformer. The other primary is going over here, has the neutral, which is switched, and then it has the other primary, and it has the other side of that lamp, and it has this cap, which has been disconnected at the other end. I'm going to wire it so the hot will go here and then to the switch, and one of the primaries will be connected to the hot through the fuse and the switch, and the other primary will go straight to neutral coming out of the new power cable. That'll be the safety code. And this Black Beauty here is a 600 volt 0.022, and I'm going to take that out very carefully and test it, because if it is good, the owner can sell it to some would-be Tone Master, Les Paul, or junior owner, etc. People pay way too much money for these things. It's probably leaky as far as high voltage goes in an amp. I'll test the 47 nanofarad that's in here as well. But for a guitar, it may be just fine as a tone capacitor, depending on what the actual capacitance is. We'll check that in a moment. Okay, while we're doing this, let's have some fun. This is that Sprague Black Beauty from this early 60s Gibson. Sprague, rather. If I measure it, 27 nanofarad. It says 22, measures 27. That's still fine for use in a guitar. Here's an orange drop. This is a 715p. Typical choice. It's also nominally a 22. Measures 21.95. That's an actual 22. Vishay MKT 1813, one of my favorites, 22.22. You won't hear any difference between these two, the way that the circuit works. That's too small a difference in actual capacitance to matter. This is a Panasonic ECQ series, also a 22 nanofarad, 22.2. So it measures pretty much the same as that Vishay. All three of these are interchangeable as far as their function in an amplifier or their function as a tone cap in a guitar. This one says 22, measures 27. If someone were to do a shootout in their guitar with these four caps, they would not hear or measure any difference between this one, and this one. They would measure a difference. They might hear a slight difference with this one because it's 27 versus 22. It's not going to be a huge difference, but there'll be a slight difference. Some of these, which say 0.022, may measure closer to 10, some 30 or 40. So you can't test old capacitors in a guitar versus other caps unless you know the actual capacitance. It does not matter what's printed on there. So if this thing actually measured like 40, Wow, listen to the difference in sound between this old one and these new ones. The old one's clearly better. The old one would clearly be different. It would be better only if you liked the sound of a larger capacitor, in which case you could buy a brand new larger capacitor cap. Or, if you pay 30 to 100 bucks for one of these things, you're going to love the hell out of any difference that you hear, even if that difference is just capacitance, not any magic from this old capacitor. Anyway, some will not believe that. Others are shouting amen. And others are saying, that makes a lot of sense. Rather than comparing different types of 22 nanofarad caps in a guitar, maybe I need to try 15 nanofarad versus 22 versus 33 versus 47 and see what I like for myself. Okay, so the resistor and the two leads are removed from these pins. It's a 1K resistor, that half watt. I'm going to put in a better one. You can see I've got the old ground wire out of here and left one of the primaries and one side of the lamp connected here, and nothing on the fuse. That'll have some new wires. And this primary and this other side of the lamp, I'm going to put a little terminal strip in here, just because it's relatively short lengths of wire, and I don't want to do a standard solder and then shrink wrap it to the neutral here. Let's turn over to this cathode bypass cap next. So this is the cathode bypass cap on the output. This is a cathode bias amp, and this is the cathode resistor there. They're in parallel with each other, just mounted off different tubes. I may revisit that once the whole thing's working. I may have to change that value for modern wall voltages. Let's get this capacitor out of place. So it's connected here to pin 3. I want to make sure that this wire does not get burned in the process. I'm going to lift it up a little bit. It's actually not a wire, it's insulation on a long cap lead. It should be just fine. So let me get in here and remove some of the old solder. This is wrapped around, so try to cut the lead a little bit without cutting the actual pin of the tube. Looks like I got it. This should lift out, and that little snippet of old looped wire on the back will come off like that, and have a nice clean hole there. Now this cap, the other end is going to the center terminal, which is at ground. Let's see how much of a wrap it has. I've worked on an awful lot of amps over the years where someone would have just snipped it right here and left the old wire in here. And over the years, old leads pile up kind of. It can be very cluttered, especially in eyelet boards. It's real important to get the old leads out whenever you at all can. All right, so this cap goes to the stash to be returned with the amp. However, this is an electrolytic, so it's not to be reused. And now I'm about to have a decision to make. Let me show you what I'm talking about. All right, the cathode resistor is going from pin 3 to ground on this terminal strip, and you have a yellow wire joining the cathodes together, and I have that capacitor going to this terminal strip. This terminal strip is that ground is made through a rivet, which is not great. Same for this one over here. In general, I would want the cathode to be referenced to ground at the same point, not some over here and some over here, especially with the rivet where they may be slightly different from each other. So I'm going to hold off on that decision. I may mount a terminal strip over here. It's going to depend on my decisions on this filter cap here that you can just see in the right corner. If I had a new terminal strip in here, or just a ground lug, really, I could just put a ground lug right here and run the cathode resistor and capacitor to ground right here or right over here. Actually, I can't do it here because of the choke, but over here, that would be better because I would be able to ensure a much better connection to chassis than through a rivet. And that would give us solid ground for that. And also put the ground for the cathode resistor and bypass cap to the same actual good ground. So I'm going to hold off on replacing that cap just right now. Let me take a look at the rest of the preamp first. All right, this one has come out pretty neatly. So new filter cap here, from this ground to here. I measured all the rivets that are grounds, and I applied a good amount of force, and there's just no wiggle there. I guess it's just going to be okay. It's been okay this long. It's not something I would prefer to do, but in this case, it seems to make the most sense. So new 20 microfarad filter cap here, new bypass cap here. I've measured this. It's just under 300 ohms. I'll be revisiting this resistor and the bias later. I went ahead and put this cathode bypass cap here for the cathode bias. I know it gets confusing, cathode bypass for the cathode bias, but trust me, it all adds up. I think if I need to change out this resistor, the new resistor will go up here and be elevated above it for some space, but that way it'll all be to this one ground node. The screen node is now mounted here, so its ground is to the stuff that the preamp is using, rather than over here. And over here, the reservoir cap is going to ground here, along with the HT center tap, and at least for now, that may stay that way. This wire, I believe, is the heater center tap, so that's all solid. I don't have insulation on these leads because there's just nothing for them to touch. They're not going to be a problem. I may put a dab of silicone beneath these, but they seem pretty nice and solid. That 1K, I put in this nice Panasonic 3-watt metal oxide. I think this is going to be better long term. I removed one Kep's nut that holds the power transformer in place and enlarged the hole in this terminal strip, put it on there, replace the Kep's nut. I'm not using it for ground or anything, just as an anchor point. Here you can see the lamp and one side of the primary is going here. That's where the neutral will go. The hot will go here, then a wire to the power switch, and the other primary on the other side of the lamp. So that will be an easy, solid way to bring this up to code, and I've not added any drill points for that. I did enlarge this hole where the grommet was from 3/8 to 1/2 inch, and I have deburred it on both sides, and that's where the new cable gland for the new power cable will go. Cable gland is an awful, awful sounding term for a very useful, nice part. Anyway, so I'm going to put the new power cable in place. I've already confirmed that's the correct 1 amp fuse, and then we'll see where we're at. I've got a couple of stray cobwebs still to fish out of this thing. I've already cleaned the 2 pots, and once the bias is set and confirmed that everything else here is working, because I have no idea if any of these other resistors will need to be changed, we may take a look at this T filter. Gibson was using these like they were going out of style. They were never in style. We'll get to that later. Sometimes Gibson in this era did some things that to modern ears are just kind of dumb/awful. And these little T filters that they like to use are a prime example of that. All right, ready to test it. And I've got it hooked up to my shop cab, and I've got it tilted up like this. This is the best way to test it on the bench without the tubes getting weird pressure on them. And I've got my light bulb limiter. I powered on for the first time. Now, while it warms up, let's see what's at the heaters. This is with 117 out of the wall right now. Though it's going to be a little bit lower because of the light bulb limiter. 6.5 on the heaters. That's good for a start. This came in originally because it was humming. Something fierce, according to the owner. And I'm hoping it's just these ancient filter caps that were in here. Hence the recap, you can see. But it could also be these ancient 6AQ5A power tubes, which are similar in a lot of ways to an EL84, though they have a lower max voltage. We'll be checking that. We'll be checking the bias and all that. Before I do anything radical, I want to see what the screen and plate voltages are. 241, so that's lower than 275. 240, and that's all good. Now I'm going to check for voltage at the grids. Make sure that the caps in front of them aren't leaking. Seems to be fine. You'll notice I've measured on pin 1 of one and pin 7 of the other. That's just a peculiarity of the Gibson layout. Pins 1 and 7 are internally connected on this tube. That's another way it differs from an EL84. That it's a 7-pin tube, but not a 9-pin tube. There's a slight hum in the background, but it's really slight. Not worried about that, given the general ground scheme and that the heater center tap is going to ground. Let's turn the volume up and see what happens. All right, hear a healthy amount of normal white noise. That's with it cranked. Tiny bit of thud in the tremolo, but the tremolo is working. It has a fixed speed. We turn the volume off. or lower. Gently tap on the tubes. A little bit of microphonics, we'll revisit that later. Let me turn the volume off, and I'm going to turn off the light bulb limiter. I don't think we're going to have any shorts. I want to see where the heater's at, where the B plus goes now, and then I'll check the bias. So 6.56 there, that's fine. That's with 116 volts out of the wall right now. And the B plus jumps all the way up to 248.9. That's no problem. So let me just grab a measurement across this cathode cap. 16.47 to 16.5. I'm just going to put in 16.5. And the bias resistor actually measures 295.6. And the plate to cathode is 232.6. And assuming 5% of the total current is screen, that sets these tubes idling at 6.15 watts. These are 12-watt tubes. That is very, very cold. Really cold. Well, I thought long and hard about the whole idling at 50% or just slightly over on the cathode bias on this amp, and I think just like the Marshall SV20, it's done for budgetary reasons. While the amp would sound an awful lot better if it did have 90 to 100 to 110% idle dissipation for a cathode bias, the way anyone actually designing an amp to be a great sounding amp would do, Matchless would go even higher than that. They used a very small power transformer. I don't think that it can handle the current if I were to increase the bias. And if I increase the bias, the B plus would drop more and more until the amp would have other issues. So I think this is probably about as good as it can be in this model with this tiny power transformer. I might be able to get it to 60%, but not to 90 to 100 to 110, which is where it really, really should be. So I think I'm going to leave well enough alone on that. It's a shame it's so small, but it's not worth changing out the transformer for a host of reasons. Number one, it would devalue the amp. Number two, if you want a bigger amp, buy a bigger amp. Anyway, back to the rest of it. Anyway, let's plug a guitar in and see where we're at. Okay, since we have an early 60s Gibson Skylark, I grabbed the reproduction of an early 60s Gibson SG on the theory that only a Gibson is good enough. And let's see where we're at. Oh, that sounds pretty good. Let me turn down the level on this mic and turn the amp up a little bit more because I think we're probably going to distort otherwise. Maybe not the best tuning-wise. It's another day of changing weather here after Tornado Alley came through the other day. But it's pretty promising. So this model does not seem to be negatively affected by that T filter. So that's good. All right, let's try the tremolo here. So the tremolo overall sounds pretty good, but there's not much difference between its slowest and fastest speed. So it's time for me to take a look at that and see what is up. It's all over here on this card, And it could be a combination of resistances. I doubt these orange drops are weak. These 225Ps tend to be pretty much bulletproof in any amp that they're put in. But it's always a first. So I'm going to take a look and see what's going on there and measure the actual resistances, see if we can get this sped up. And it's possible that the circuit just sounds like this, in which case I'll talk to the owner about whether he wants me to give it a slower minimum or a faster maximum or whatever. The amp overall, though, is really sounding nice. I hope the speaker's good. I haven't tested the original speaker yet, but so far, very, very promising. Well, I went through and measured everything in the vibrato circuit, and everything you just heard is what was designed. So it goes from kind of slow to a little bit faster than that. For fun, and so the owner can make a decision, I put another 22 across this 22. It's temp 10. I can take it back out. You'd never know it was there. And it does slow down the minimum by a nice amount. It's still not the world's most versatile vibrato, tremolo, whatever you want to call it, but it sounds good. It's the kind of thing it could be played around with. I think the one in the GA18T is a better sounding tremolo, but not everything needs to be changed just because. Speaking of which, a lot of guys out there increase the value of this cap and or remove that T filter, and they say the amp is tinny without it. I'm listening to my 2x12 shop cab, and the amp actually sounds pretty good. It doesn't have the lows of a deluxe reverb, but neither does this little pair of 6QA5As or the tiny output transformer have the ability to reproduce really huge low end. So I think it's probably pretty nice sounding amp. I think if anything, the old speaker might be what people are complaining about. It's on the small side. Let me get that set up and see if I can figure out a way to have this out of the cab and the speaker attached to the baffle out of the cab and get any kind of usable idea of what it sounds like. I at least should be able to find out whether the speaker's any good. All right, I got the speaker hooked up, just propped up on the bench. Due to the way this amp is constructed, I can't test it all in situ yet. So that's neck pickup on the SG. We may yet determine that this is just a very, very bright speaker, but the speaker mounted to the baffle and then in free space is not going to have the low end that it would have when the baffle is mounted in the cabinet. So I'm really just seeing if the speaker has any problem frequencies. And so far, it's pretty good. That's one of the hazards of trying to add low end in the amp by changing a component. If the speaker just doesn't have much lows, then you end up radically increasing the low end without really hearing what you're doing, and you can introduce other problems into the circuit. So I won't know for sure till I do have a speaker back in place, because this same thing through my cab sounds radically different. But before I do that, I want to show this video to the owner and talk to him about maybe either making a permanent parallel capacitor here to slow down the minimum speed on the tremolo, or just replacing this orange drop with the 0.047 orange drop. Everything else in here seems quite good. Even that old Black Beauty there is fine. That is the tremolo cap. Should it go wrong, the only thing that would happen is the tremolo would stop trimming. The amp would still work just fine without that, so I don't see any need to change it out preemptively. But yeah, stock speaker floating in space is pain.